topics very clearly in depth. Otherwise, you might face some problems in later life or even in interview board. Because I tell you, in the interview board, they will not ask you to deduce a very large sort of deductions or large questions, complex questions. They will not ask you. They will ask you the very basic principles, fundamentals of all the devices, all the principles, all the topics. So this is very important one to make the things clear. Try to be inquisitive in mind, because engineering study is you raise your questions yourself. Open your mind, ask yourselves what are the reason of happening these things. To give you an example, transformer code. Transformer, you have gone through transformers. Now, if somebody asks you what is the role of code, then what are the materials normally used in code? Now, if you use wood, for example, instead of normal core material, if you use wood cart, what will be the consequence? Or even gold, if somebody asks you, oil, construct engineer, could you please design a transformer using a gold as a core? I have gold and I have no problem. I have money, so I want to see a transformer having used the core as a material, gold as a core material. What will be the consequence? So this sort of very basic fundamentals. To give you another example, you have gone through the induction motors. If it is a three-phase induction motors, then you know if the motor is under loading conditions, it will take power from the systems, supply systems. That power constitutes two parts. It will have two parts, the real power and another one is reactive power. Now the question might be there, what the real power is being done, that is being doing in the machines, in the motor, and what the reactive power is doing in the machines, or what is the role of reactive power in the motor and role of reactive power in the motor. So these are very basic questions. Let's call a three-phase winding, the rotor winding is three-phase rotor winding. If rotor, one of the windings, one phase of the windings of the rotor is open circuited, what will happen with the motor functions? How it functions? These are very basic idea, very basic questions. You need to develop yourself these questions and try to sort out the answers. These are very fundamentals. You have finished all these courses in earlier semesters. So engineering study, for engineering studies, not to just read and memorize all the things and write down in the exam. It's not really that. You need to make the things clear, understand properly, then you will get the real test of engineering. This is my suggestions is try to understand and try to raise the questions within yourselves on any topics. Then try to sort out the answers. If you cannot, then ask the faculty members, teachers. So from my question and from my course as well, I will prefer, I will really invite you to ask questions. You stop me there on my lectures, in any stage of my lecturing period, and then raise the questions, ask me, make the things clear. But it doesn't mean I know the answers of all the questions. If I do not know the answers straight away, if I cannot give you the answers right now, the right way, then I will sort it out for you in the next class. I will give it to you. But for God's sake, don't leave the things unanswered. Make it clear, very clear. This is the fundamental points from my side. So ask me questions. Make the things clear, read carefully, understand. Of course, there are some points which you need to memorize, but there are some conceptual issues there which need to be understand, we need to be understood very clearly and in depth. That's my points. So I will not mind, again, I will not mind if you ask me questions at any stage of my talk. Now, the topics this course for this one, as you know that the power system 2, the name of this course is power system 2. Now, can you see the board?
Yes,
Can
sir.
you see the board?
Yes, sir.
Yes, sir.
Oh, that. Now, let me explain or discuss the objective of studying this course. What are the usefulness of studying this course? How it will help in our life, in our engineering practicing life. This course, I will try to just discuss this briefly. Now, initially, before 2014, the name of this course was Power System Analysis. Power System Analysis. This was the title of the course. Now it has been converted to Power System 2, as you know that, Power System 2. Now, in fact, this course, even now, is the mean for analysis of power systems. This is the main objectives. Analysis or diagnosis or diagnose is power systems. What is diagnosis or analysis? I will explain it gradually. Now, before that, you need to understand the power systems. You have gone through in your 3-2 course power system 1. There are major 3 components in these power systems. One is generation, then next is transmission, my handwriting is not very good, so please bear with me, and then distribution. These 3 major components of power systems. You have gone through in your previous semesters. The generator, the construction, the operating principles, how the generator behaves under no load conditions, under full load conditions, or even under short circuit conditions. So you have gone through in details of this generator. Then in the transmission line as well, the transmission systems, how the transmission systems can be modeled, we have gone through in details. Just a second. Now, the transmission in the power system 1, you have gone through how the transmission lines can be modeled. You have studied it in details. How the transmission line behaves under different conditions, like under no load condition, under full load condition, or you have gone through in details. During no load means under off-peak hour or very low load period, and very high loaded conditions, how the transmission line behaves. We have studied this in the previous semesters, earlier second semester. And then distribution systems. Distributions, after transmission, the power will be available to the consumers at different voltage levels, those peaks are called the distribution systems. I mean, where the power is being distributed to the consumers. So that deals with the distribution systems. The distribution, it seems to be simple, but to design a very large city having a very high amount of load is not so simple, I tell you. It is a very complicated, complex. And particularly if you want to maintain this supply security, it means there will have no power uh, interruption at any time, 24 hours a day, the power will be available. That's security, to maintain the security, supply continuity, and the distribution system design is really complex, particularly for a high load like Dhaka city. Is a very complicated system as well, not simple. But anyway, you have gone through so far of standalone of principles. I mean, the generator of its own, you have gone through it. The transmission systems, independently, you have gone through the transmission systems, and similarly the distribution systems. But when these three components, if you put them together, then its system is called the power systems. And power systems like the human systems, human body, there are many components: hand, head, stomach, leg, all these components are there, and all the components have got their, of course, special meanings and objective of individual components. And when all these components are putting together, then human is a human being. পরে পরে আমার পরে হবে, তুমি একটু পরে যাও, দরজাটা বন্ধ করো। So when all these components are connected together and operate in parallel, like the power systems, let us take an example. A fan is moving in your room, taking power from your distribution transformer, 11 kV or 400 voltage line, single line to ground power, a single line to line, or a line to ground neutral, and that power is being taken from an 11 kV side through a transformer, of course. And 11 kV is coming from the 33 kV, 33 kV is from 132 kV, and then 400 kV and so on, and eventually from jack. So the power which is being consumed by the fan is being produced, generated by the jack. That power is being carried through all the way at different voltage levels, but is operating in parallel because the many generators are operating in parallel, many transmission lines are in parallel, and the distribution system as well. So when all these are operating in parallel, there will have certainly different problems of these power systems, different nature of problems. Like, to give you an example, human being, as I said, different components are there: hand, legs, head, stomach, all these. When put together, then it's called the human body, and it's live human body. So a live human body will have certainly different nature of problems. Different times, different nature of problems might be developed, right from headache to heart failure. So you see, if you go to a doctor, then they will diagnose the problems first, and then according to the diagnosis report, they will select the drug. Let's call for headache, they will select a paracetamol, perhaps it will be enough. But for a heart attack, certainly paracetamol will not do the job. They will go for another sort of very serious, fast-acting treatment. In the power system as well, during its operation, parallel operation, there will have different nature of problems. That problems, the objective of this course is to detect, diagnosis the problems, and that determine the depth of that problems. You see, this is the main objective of this course for System 2 course. So during a parallel operation of this entire systems having three different components, result components, and there will have different problems. So the power system engineers will diagnose those problems and detect or get the results there. These data, these results, the analysis results will be handed over to protection engineers continuously, all the times. And according to the problems, the protection engineers will select the protection schemes, like the drug. Doctors, they will select the drug. Here, the protection engineers will select the protection schemes. For a simple problem, they will select a very simple protection scheme of cheap and simple protection schemes. But for a very major problems, where the chance of chance of destruction of these power systems is high. So in that case, the protection engineers will select a very high speed, and it will be expensive, of course, protection schemes to protect these sort of systems against those problems. So these are the very basic objective of this course: to analyze, to detect, to diagnose the different natures of problems of a power systems operating in parallel. You got the point? So this is the very basic points of, or very basic requirements of studying this power systems course. I mean, power systems course, power systems, this study, without this result of this study, the protection engineers cannot select the protection schemes, because I mean, certainly to build a power systems, you have spent billions of taka, and you cannot avoid occurring any problems. There will have different nature of problems, and so protection, the system engineer or the country or the engineers cannot sit idle. Well, let's see what happens. The problems is there, so let's see what happens. It's not like that. যেমন নাকি একজন রোগী যদি অসুস্থ হয়, certainly আমরা তো বসে থাকি না, দেখি না কি হয়। আমরা we bring him to the doctor diagnosis, and then select the medicine. Here, the protection and the system engineers will detect or identify or get the results of different nature of problems, the depth of the problems, and then those data will be utilized by the protection engineers to save the systems. So this is the very basic points or basic objective of this studying of this course. Now, I will rather share the screen now to give you the glimpse of the courses. I will share first. Can you see the screen? Can you see the screen?
Yes, sir.
That's good.
Yes, sir.
Now, the topics of this, the chapters or topics I will cover in this syllabus. I will give you the idea of using the board. Topics to be covered in this syllabus, in this course, is first is PU system, Then chapter 2 is the load flow studies. Then chapter 3 is symmetrical form. Studies. Then this is S4. Chapter 4 is unsymmetrical form. This is A. Unsymmetrical form studies. Then stability studies. And finally, if I get time, then harmonics. I will try to discuss for the harmonics. So these are the different topics of the chapters, not precisely the chapters. I will try to cover in this syllabus. Now, the books I will try to follow. There are many reference books, you see. You can see there in the very top of this page, the elements of power system analysis is a W.D. Stevenson Jr. is edition 4, 4th edition. Then modern power system analysis, Nagrath and Kothari, Indian book. Electrical power systems, C.L. Wada, and electric energy systems theory and introduction, Y. Elgard. These books, all these books are available in the market. It is not very expensive. You will get these books in the market. So the top one is already, I suppose, with you, W.D. Stevenson, Power System Analysis. These books you can purchase, you can have one copy of those. And the energy systems might not be available in the market, but there are few copies I have photocopied from my original book and press it to the library. So these are the very 4 books I will try to follow in my lectures. There are many other reference books as well. So I will not keep this for the time being, it will be not very useful. And the topics, as I said, in the whole, we will start with the PU systems. We will use the PU systems. In the first page, there are very basic points of that. I mean, in the world, there are 2 frequency systems are being used in different parts of the country in the world, like America, South America, and other related countries like France. Those countries, the 60 Hertz power system are being used, whereas the Commonwealth countries like the British and Commonwealth countries using the 50 Hertz systems. Well, the questions might be there. Why these 2 different systems? What are the use and what are the advantages or disadvantages of these systems? I mean, to explain these things, there is the very basic points are need attention over there. You see, for 60 Hertz system, you know that if it is a 60 Hertz generator, 2-pole machine, then its RPM will be 3600 RPM. And if it is a 3600 RPM, and if it is a 50 Hertz, then 2-pole generator will have 3000 RPM. You got the point. Now, higher the RPM, I mean higher for 60 Hertz, the speed is high, RPM is very high. It means centrifugal force near the surface of the rotor body is very high. if you keep on increasing the frequency or the speed of the rotor, there will have certainly the chance of metallurgical failure of the rotor. So this is the, it means energy, you know, the half energy is half mv square. You have gone through this in your physics courses, something like that. Energy this is v, velocity, whatever. It means for 60 hertz and 50 hertz system, you can think of this equation. Energy, if it is a 60 hertz systems of, let's call 100 MVA motor generator, the speed is high, is 3600, so its mass will be smaller to maintain 100 MVA. You got the point? So it means 60 hertz systems, the rotor mass will be smaller in size in comparison with 50 hertz systems. 50 hertz system, on the other hand, the same energy, 100 MVA, the speed is low, so the mass will be a little bit higher. That means dia of the rotor will be higher. The mass will be higher. You see? And accordingly, the size of the generator. That's very simple points that they are mentioned there. And another point is that 50 hertz systems, the impedance of the transmission lines, the winding of all the devices will be, the impedance is, you know, omega L. So omega means twice pi L. So F is smaller, then impedance will be smaller. So in 50 hertz systems, the impedance of all the devices, the transmission line, generator, winding, and all these windings will be smaller in comparison with 60 hertz systems. You got the point? This is the very basic points. Other than those, I'm not very sure, but anyway, those 2 points I can guess. Now, this is the very basic improvement, gradual development of generating capacity of the machines. In early days, generating capacity of small machines are there. They used to manufacture small machines, but with time, as the load has been increased significantly, the demand of producing, manufacturing higher rated machines is increasing as well. So it means with time, the size of the machines are being increased gradually. So there are a few points over there. The advantage of increasing transmission voltage. You have gone through in your second year power system 1 courses. Advantage of increasing transmission voltage. Now, let's come to this point, per unit systems. You see this, in short, we call PU systems. In short, we call this one as a PU systems, per unit systems. The very definition of PU system is this. It is the ratio of PU per unit quantity or per unit system, whatever, is actual quantity divided by base quantity. The unit of, if it is a voltage, say for example voltage, then actual quantity unit, actual quantity, if it is a voltage, then if the unit is kV, then the base quantity will be again voltage and its unit will be kV as well. If it is ampere, then the base quantity will be in ampere. If it is actual quantity is kiloampere, the base quantity must be in kiloampere. So this is the ratio of actual quantity divided by the base quantity. Because the unit is same, so it means it is a dimensionless. It's a simply a ratio of two things. It's a simple ratio. To give you an example, let me take this very simple example. let's call the value of this voltage is 18 kV. Let's call 18 kV. We want to convert this 18 kV voltage to PU value. So to calculate the PU value of this 18 kV, first and foremost duty is to choose a base quantity, base voltage. So if you select a base, we call base in a base, is 20 kV. If we choose let or choose or whatever, if we select 20 kV base, then the actual voltage, this voltage of this 18 kV in PU will be 18 actual quantity divided by your selected base quantity, and it will be less than 0.9 in PU. Got the point? But it is meaningless unless you say this value has been calculated on 20 kV base. So base is important. Base is very important. Somebody asked me in the previous section B, so why you should choose the base value, the base quantity? What is the use of selecting or choosing a base quantity? The answer is simply, let me tell you, I'm not very sure. Can you see my hands? If somebody show the hand like this, can you see my hands there?
Yes, sir.
Now, if I say today I purchase a fish of this size from the market. So what is the meaning of this size? Just I set my hand like this. So what is the actual length or height of that fish? Is it from the floor or from the ground floor? I am in the second floor. So is it from the ground floor or the floor from this first floor of this floor? Or if I set my hand there of this size, you got the point. So I need to set a reference value. If I said I purchase a fish of this size, means what is the base value? It is the floor. The floor is the base value. That means from the floor it will be, let's call is 3 feet or 4 feet. If it is from the ground floor, then it will be perhaps 13 feet. So, and if I set my hand over there, if I see the base there, then it will be perhaps 6 inches. So without a base, selecting a base, PU quantity cannot calculate the P values, PU quantity. You got the point? So PU value is very important. You can check it. If I select, instead of 20 kV, if I select, let's call 25 kV, got the point? I select 25 kV as the base value or the reference value. Base means the reference value. Then the value of this one will be 18 divided by 25, and its value will be certainly less than 0.9. It will be something less than 0.9. Got the point? And that will be the P value. But on that base, this value is on this base. This value, I do not know, let's call it 0.6. This value is on this base. So base is important. You need to select a base properly. This is PU quantity, sometimes we call PU or in percent. If it is in percent, then it will be 90%. It will be 60%. Got the point? It can be expressed in percent or in PU. But to calculate the PU value of any quantity, you need to use the base quantity. So this is the very important one. Now, that's why the definition per unit quantity can be defined as the ratio of actual quantity and base quantity. Actual quantity, if the unit of this actual quantity is in kV, then base quantity must be in kV. If the actual quantity in kiloampere, then the base quantity will be in kiloampere as well. So it means it is the ratio of same quantities as dimensionless. There will have no unit of this one, it is simple ratio. That's why I say that it is dimensionless. I got the point. Now, what is the advantage of calculating these p values? What is the use of these p values? To give an example, use of these p values, I can take an example there. Let's call a generator producing power is going to a transmission line, stepping up the voltage. Then this transmission line is going there. I have made a substation there. Hello. Another transformer. I'm going to see. কিন্তু আমার তো দেরি হবে না আপনি তো মুছে দিন না আমার দেরি হবে একটু দেরি হবে এখন তোমার সব শেষ ওদিকে শেষ হয় ঠিক আছে সারো আগে সারো তারপরে আজকে এখানে শুধু then this is another transmission line, another substation. This is another transformer for stepping down, another transmission line for distribution voltage types. The loads are there. You see, less generator is generating power at 11 kV. The transformer is stepping up the voltage to, let's call 230 kV. From there, this transformer is being used to step down the voltage from 230 to 132 kV. There is 33 kV. Got the point? Then there is the 11 kV. Now this circuit, this is this one circuit, this is another line. These are 11 kV. The loads are there, and there is a one circuit load. Let's call 1 MVA load. 1 MVA load. This 1 MVA load, how much current will be there? You can calculate. That 1 MVA load, it will be supplied by the generator, and how much current will be there to produce to give this 1 MVA load, you can calculate. It will have some value. If you refer this current to this circuit, certainly the current will be changed. Right? Ekhane voltage 11 kV, ekhane 230 kV. So the current will be reduced. So current will be changed. That same load, if you consider this 130 kV, the current will be again changed due to this transformer. The current will be in 33 kV, it will be again changed. And in the 11 kV, it will be changed. So it means every stage of the transmission of the systems, power systems, the power to handle a certain amount of power, the current is changed from voltage level to voltage level. So it means you have to calculate the current of all these, using the proper current of all these values from different voltage levels. And that will have every possibility that you will do the mistakes in calculating the current and voltage levels. On the other hand, if you manage to calculate the P value of this power, the current, you can calculate the current there, the same PU, same amount of PU, current PU will be everywhere, will be very same. The current magnitude will not be, in PU, the current value will not be changed. So this is one beauty. So the impedance, the voltage is exactly the same thing. You know the impedance of this winding of this generator. If you refer it to this side, the impedance will be changed. If you refer this side, impedance will be changed. And everywhere the voltage level has been used. Everywhere the transformers are there, it means the voltage, the current, the impedance will be modified. But if you manage to calculate the P value of anything, the impedance or the current or the voltage, then it will remain same throughout the network. Wherever the voltage level, doesn't matter. So these are the very beauty of this power, PU systems. These advantages of power systems, PU systems, has been mentioned in these points there. There are 4 points there. In the exam, it's the Stevenson book from the Stevenson, exactly from the Stevenson book, chapter 4, edition 4, is section 6, chapter 6, section 613. You will find these advantages, and it is written there. So those are the advantages. In the exam, sometimes you set questions. What are the advantages of PU system? So you need to go through all these points. I have already discussed these points. Now, the question is PU systems. Without understanding properly the PU systems, you cannot solve the problems of next any chapters. It's very important because all the rest of the chapters, the PU are being used to solve the problems. Just can I take a break of 5 minutes break? Can I take, please, 5 minutes break?
Yes, sir.
Yes, sir.
5 minutes break. Okay. Time
আমরা সেটাকে মুছে দেব
কথা বলবো I'm sorry really just for interruption. Are you there? আছো তো তোমরা সবাই?
Yes, sir.
আচ্ছা ঠিক আছে তাহলে আমি next. So as I told you that you understand PU system is very important. You will have to understand properly the PU system, without understanding the PU system, because this tool will be used in solving the problems of rest of the chapters. Everywhere the problems, to solve the problems, you will use these PU values, the PU systems. So PU is very important. So let us start from the PU, how this things is being built up. Gradually I will start. Now, you see, our objective is to calculate the impedance, is a Z actual, we call the Z actual, the impedance of anything, any winding or whatever the things. This we call, this is a Z actual. This is the actual impedance of any winding or whatever.